So now, you know all about binary, right? So we're ready to completely switch from thinking in regular numbers to thinking in binary. Yeah, not so fast. Even the most dedicated computer scientists still need to live in both worlds. They need to be able to make the jump from binary to decimal numbers and back again all the time. In this lesson, you'll have the opportunity to get some practice with base conversions. Last lesson, we talked a lot, perhaps more than you cared for, about number bases. For example, our decimal number system has a base of 10 and binary has a base of 2. There are actually, if you're interested in some ancient history, there were native groups in Central and South America that operated on even different number systems, like 7. So it's pretty interesting how our number system has evolved, base 10. Perhaps you would guess because when we first started counting, we needed our fingers and toes, and we've got 10 of each. And the binary number system evolved from base 2, believe it or not, because in the old days, computers were programmed by punch card. And you know what a hole punch does to a piece of cardstock. And the hole punch would mean that either there was value in that particular place or there wasn't. And so that's how we got this 0-1 connection, electrical current, no current kind of thing going on. Pretty interesting. If you ever want to learn about some history, go check out the 1880 census and find out what that had to do with computers and with why we are operating in base 2 when we use computers. Anyways, we learned that any number in any base, the value of the number is determined by going place value by place value. And at every place value, we know that whatever the base is going to be raised to some exponent. And as we move to the left, for example, starting over here, 10 to the 0 power, as we move to the left, that power increases by 1, 10 to the first. And as we increasingly move to the left, that power increases by 2. Same thing over here, except for this is base 2. We start off at 0, the power increases by 1. And again, and so on and so forth, right? And we know that all we have to do, whatever digit occupies that place, we know that that has to do with what value it is, and we multiply the two together to determine what that overall value is. When we have all the overall values determined, we just add them up. And that was that fancy summation thing that we looked at. We add them up, and we get the overall number. That was just a quick review on how to interpret numbers in various bases. And in this lesson, we're actually going to talk about how to convert those numbers between the bases. On the APCSP exam, you will absolutely need to convert binary numbers into decimal numbers or decimal numbers into binary numbers. And additionally, you may need to convert something called octal numbers, or you may need to be familiar with a base 8 number system or a base 16 number system. And we're going to talk about those. But right now, let's just keep it simple. Let's just talk about base 10 and base 2. So you're going to take a look at a scratch demo called The Amazing Binary, and the Amazing Binary, which is the wizard from the gallery, can convert any decimal number that the user types in. You'll recognize the familiar ask and answer type deal into its binary representation. And so your job is to think about how the wizard is doing that. And the key here is going to be to think about that dichotomous relationship that we talked about in the last lesson. So dichotomous meant there's only 2 possible answers. Yes, no, true, false. And in particular, you might want to start thinking about odd, even. That's another dichotomous relationship. So let's take a look at this. All right, so I told you that I had a little bit of a different way to show you the base 10 number system and the base 2 number system and how it all works together. I just wanted to show you a spreadsheet that I make, and I oftentimes have my students make this spreadsheet. So this row right here tells us the place value words, and this is for the base 10 number system, right? So we're very familiar with these. We've got ones, tens, hundreds, thousands, 10,000s, yada yada. All right, and if we had 8 numbers, 8 place values, we could get up to the 10 millions place. All right, and we said that this is represented by 10 to the 0 power. The second place is 10 to the first power and 10 to the second power. If you're not used to seeing this notation here. So right here, for example, this little caret, that's what that's called. That's a caret. If you're on a regular keyboard, it's Shift and 6. Otherwise, you have to go to your alternate keyboard. It is the notation for raising a number to a certain power. So it's assumed that the number on the left side of the caret is the base, and the number on the right side of the caret is the exponent. And the caret indicates that you are raising it to that exponent. So we have 10 caret 0, 10 caret 1, 10 caret 2, showing us our different place values. Then we go over here and we can see that these are the actual representations of these numbers. And I want to show you something. If you haven't worked with spreadsheet programs before, I want you to see that up here, it shows a formula. I had to actually type in equals 10 caret 7 and hit enter. And what a spreadsheet program will do for you is it'll automatically make that calculation. All right. So for example, in the next one over here, up here you can see that this is equals 10 to the 6th, and it's actually even showing me the value there. Okay, so that's what I did there. And then down here, it says number in expanded form. So in here, I know that for the base 10 number system, I can type in any number at all. I can make this 7 instead of 9. Okay, I could make this 5 instead of 9, because I know that I can put any number 0 through 9 in this box right here. All right, so what this is doing for me is it is multiplying whatever number is here by the place value of that number, okay, to determine the value of that place. And so it's a nice little formula. And same here. It's multiplying the orange box times the purple box to give me the value of that place. All right, and then remember that fancy summation symbol that we looked at? Well, that just means that what I do is I add up all of these different values, and that actually gives me the value of this number. So the value of 536111091 in decimal is this right here. And the way that I get it is by adding up all these individual numbers that are made by multiplying the number that occupies the place times the place value and adding them all together, right? So that's just, I guess, kind of maybe a little bit longer, but a little more clear way of showing you what was going on. All right, so let's click over here to base 2. All right, now I have this set up a little bit differently. We know that in base 2, we can only type in the numbers 0 and 1. And I've got this set, I use some conditional formatting, that if I type the number 0, it's actually going to turn black. And that represents the circuit being off, because these are 8 bits right here. So this is like 1 byte of memory in the computer. And it's representing that if the byte were 000111111, it would look like this. It would be off, 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 on, right? Anyways, but I'm going to put that back. Let's see. I'll leave those 2. Okay, so same exact thing that happened there over at base 10. This is equal to 2 to the 7th. That's the value of this place. The value of this place is 2 to the 6th. This is 2 to the 4th and 2 to the 2nd, right? And I know that whatever number is here determines what number I multiply that place value by. And it's either going to be a 1, meaning I have that value, or it's going to be a 0, meaning I don't, right? So 0 times 64 is 0. So it's a total of 0 for that place. All right, and then this box right here adds up all of those numbers that I see on the bottom and returns the value. All right, and then since that's the decimal number, the binary number is right here. Okay, and I used a formula to convert a decimal number to a binary number and reference this cell. So whatever number this cell has, it shows that number in binary. Okay, so that's what that looks like. So it's a pretty cool thing. So it works out mathematically. It's really nice and neat. And again, maybe you're not as familiar with your powers of 2 as you are with your powers of 10, but the good news is you don't need to worry about any numbers except for 0 and 1 occupying those places. Just to show you a little bit else what's here, It looks black, but there's actually a 0 there. And this looks yellow, but there's actually a 1 there. So something that you can do, starting with the numbers 32, and the reason to start with the number 32 and not with anything before that is that when we get to talk about the ASCII system, 32 is the space, represents space. And so it starts representing the actual keyboard characters that we type. And so that is 32, which means that there is a 0 in the 128th place, a 0 in the 64th place, a 1, remember up here, this is a 1 in the 32's place, meaning that that circuit is on, and then all of the other ones are off, right? We don't have any more. To get the next number, all I have to do is take that 32, and if I want to make 33, all I have to do is add 1, right? So there's 33. If I want to make 34, I just need 32 plus 2. There we go. There it is. And if I want to make 35, I just need 34 plus 1. There you go. All right, now I don't want to give you a headache or anything like that, but I'm going to scroll through and I want you to watch. Right now, I'm going to scroll through and I want you to watch this column right here, okay? Here we go. Scrolling, scrolling. You are getting very sleepy. Just kidding. But, and that's probably enough scrolling, right? I only went down to 122. But do you see the pattern? It's really easy to pick up on when it's just on and off or black and yellow. The ones place changes from a 0 to 1 every 1. Okay, you probably already know where I'm going, but just play along. Here we go. I'm going to scroll again. Watch the pattern in the 2's place. Right? In the 2's place, it changes from on to off every 2 places. All right, so this is kind of anticlimactic now, but you can see here that in the 4's place, again, changes from a 0 to a 1 every 4, and every 8, and every 16, and every 32, and every 64, right? And I didn't go far enough to make the 128. But now I'm not going to highlight anything, and I just want you to watch the overall pattern, okay? Watch that pattern change. It's a really neat visual. Cool, huh? All right, so if you're more of a visual person, this might actually help you understand binary numbers a little bit better and how they can represent any of the decimal values that we can think of, and how we can use an 8-bit binary number to represent the numbers all the way from 0 to 255. Something fun to do, I had my students try to make a piece of art using binary. So like, for example, they had to put certain numbers together to make a pattern. So this is the number 68, 0, 1, 0, 0, 0, 1, 0, 0. This is the number 170, and then repeat the number 133 times, and then back to 68, and then closing it up with the 40 and then the 16. So, and it makes a little heart. That's kind of cool, huh? And over here, I just used the actual formula just to show, so you can kind of scroll through and see the numbers change as they go. I think for this one I did go. Oh, and I also have some ASCII notation or equivalents in here. We'll talk more about that later. All right, so there's more than you ever wanted to know about decimal and binary systems using an Excel spreadsheet. How about that? So as I mentioned previously, now that you've had an experience with the amazing binary and looking at dichotomous relationships and converting decimal to binary, just a reminder, yes, this is a skill that you're going to need to use for the test. So how can you practice this? Well, there are several games that you have the option to use to practice, and all of them are really good. Some of them are actually used by professionals who are trying to study for various IT certifications and things. So enjoy practicing, and even if it seems a little bit tricky still, I think after you do some practice and play these games, I think you'll get the hang of it.